In this video, we're going to look at solving an absolute value equation, and notice that we have two things going on in this equation. First of all, we have a number that's in front of the absolute value symbol, and it's being multiplied to the expression that's inside, that's written in black. Notice also we have a value at the very end, a constant, -9, and it's being subtracted from that absolute value. So what I would recommend is treat this absolute value expression just as if it were a single variable. In other words, we're going to move everything away from it and try to isolate it before we go any further. So to show you what I mean by that, I'm going to go ahead and draw a line through my equal sign. I want to take care of this subtraction first, then we'll take care of this multiplication over here on this side. So I have this being subtracted, so I'm going to do the inverse operation, which is to go ahead and add 9. And just keep in mind, right, you have a -9 plus 9. And whenever we combine that, it's just going to go ahead and zero it out, right? So I can cancel it. Now you have to remember that if you added 9 to the left side of the equation, you got to go ahead and add 9 to the right side. So I'm going to go to my calculator and do 57 plus 9, and then it equals 66. So I'm going to go ahead and bring that answer down here and write it by itself, 66. Now the next thing I want to do is I want to deal with this 6 over here. But let me go ahead and bring this down so you can see that all we got left to do is to get rid of that 6 that's in green. Now anytime you have a number beside absolute value, it is being multiplied. So imagine there's a multiplication sign here. And to get rid of it, I got to do the opposite of multiplying, which is dividing. So I'm going to draw a division sign, which is a fraction bar, just means divide. And I'm going to divide by that number and treat it just as if it's a coefficient to a variable. Now I know 6 divided by 6 is just 1, right? And just to prove to you what I'm talking about, if I said 6 divided by 6, it would give me 1. Or if I set it up using alpha y equals inner as a fraction, 6 over 6. So this basically becomes a 1, and 1 times this absolute value expression is just going to be itself. So I'm just going to rewrite it now all by itself. 1 minus 5x. Now because I divided by 6 on the left, I also must divide by 6 on the right, right? Because we have to keep this equation balanced. So I'm going to go ahead and use alpha y equals inner, because I want to keep this as a fraction if it doesn't divide in evenly, and I'll do 66 divided by 6. Or if we write it as a fraction, 66 over 6. Hit enter, and notice it gives me 11. So I'm going to write an 11 right here. So we're almost done at this point. So now we're ready to go ahead and set up two equations from this. Now that we have it written, the absolute value of 1 minus 5x is equal to 11. Because notice we don't have any numbers being added or subtracted. We don't have any numbers being multiplied or divided to it. So now we're going to turn this into two different equations. The first one's going to be just as it's written, 1 minus 5x is equal to 11. And then the second, we're going to turn that 11 into a -11. So then I'll have 1 minus 5x equals -11. Alright, so what I'm going to do at this point is I'm going to solve the one on the left first. So I'm going to move it up so you can see it. And I'm going to draw my line through my equal sign. And I want to first move this 1 over to the right side. So I'm going to subtract it because right now that's a positive 1. 1 minus 1 is 0, so I'm going to cancel it out. And then I'm going to go ahead and subtract 1 from the right side. And 11 minus 1 leaves me with 10. I'm simply going to bring down the -5x. I haven't done nothing with it yet. But now I want to get rid of this -5 that's being multiplied to my x. And the opposite of multiplying is dividing. So I'm going to divide by -5 on both sides. And anything divided by itself is just 1, so I can say they cancel. And I'm simply left with x is equal to, and then I have 10 divided by -5. So I'm going to use alpha y equals inner, and I'm going to type 10 in my numerator, and then go ahead and type -5 in my denominator. Hit enter, and notice it gives me -2. So this becomes -2, and that's one of my solutions. Now I'm going to do this problem over here on the right using the same method. So I'll go ahead and subtract 1 from both sides. Now here I have negative 11 plus negative 1. So I'm going to put that in the calculator. Negative 11 plus negative 1. Now notice when I took negative 11 and added it to negative 1, it actually gave me negative 12 in the calculator. So I'm going to write that answer, negative 12. I'm then going to go ahead and bring down my negative 5x. And the next step is I want to get rid of this negative 5, the coefficient of x. So I'm going to do that by dividing, because right now negative 5 is being multiplied to x. And the opposite of multiplying, or the inverse operation to multiplying, is going to be dividing. So I draw my fraction bar, meaning that I'm dividing, and I divide by negative 5. Now whatever I do to the left side, I got to do to the right side. So I'm also going to divide by negative 5 on the right side. Now we know that any number can go to itself one time, so I'm just going to cross these out, and it just leaves us with simply 1x. We don't have to write the 1 in front, right, because it's an invisible 1. And then now we're going to go ahead and put negative 12 over negative 5 in our calculator. So I'm going to hit alpha y equals enter, because we always want to check and make sure that that fraction can't be simplified. And that's why you always see me using this alpha y equals enter function in the calculator. Because if it can be simplified, we need to write the simplified answer. So I'm going to put negative 5. Now notice all it did was have a sign change, right? So the numbers look like they stayed the same, but that negative sign is gone now, and it's a positive 12 over 5. So x equals 12 over 5. And that is my second solution. Now one thing I want to remind you is on these you can actually check and see if you got it right by also graphing one of these functions. So there's a trick to it. I'm going to show you how you can check to see if you got every one of these problems that you do that look similar correct. So while this is the answer, and that's what you would write down if you're showing your work, I'm going to do something just a little different to show you how we could check this. Now I'm going to go ahead and rewrite this one more time. So I got 6, right, over 1 minus 5x. Close that bracket for the absolute value, and then we have minus 9 and equals 57. Now if we want to check for the solutions with the calculator, so I'm going to write right here, check solution with calculator. We have to take this equation and we have to set it equal to 0. So unlike what we did in the beginning where we moved the 9 over and then divided out the 6, I'm actually going to take this 57 right here and move it over to the left hand side of the equation. So I'm going to subtract 57 from both sides. Now it's going to be equal to 0 over here. And then I'm going to do negative 9 plus negative 57. So negative 9 plus negative 57. And notice it gives me negative 66. So negative 66. I'm going to go ahead and just bring everything else down. 1 minus 5x. Bring down my absolute value bars and my 6. And what I'm going to do is I'm going to put this into the calculator. And when I say this problem right here, I'm actually going to graph it. And then I'm going to look and see where my graph crosses the x-axis. And where it crosses the x-axis should be at negative 2 and at positive 12 over 5. And we're going to verify that. So then you can see that you can actually check your answer by graphing this. The only thing is you do have to make sure that it is set equal to 0 to do this. Now I'm going to go to my calculator. I'm going to hit y equals, right? That pulls up your graphing function. And now we're going to type this in. So I'm going to type in my 6. And if you've never entered an absolute value equation into your calculator, you want to hit the math button to get your absolute value option. Now once you hit math, you do have to click to the right on this paddle on the top right one time to go to number. And notice it says option 1 is ABS, and it has a parenthesis here. That is your absolute value function. So I'm going to hit enter. And notice I got absolute value brackets now. And I'm going to type in 1 minus 5x. Now I'm going to click to the right to get out of the absolute value bracket. And I'm now going to go ahead and put my minus 66. And I'm going to go ahead from this point and hit graph. So you can see this function, and you can see that it crosses, it looks like right here, at -2. And notice that's what we had for our solution, so that means I did that equation correctly. It's at -2. And on the right, it looks like it's a little bit past 2. So if we wanted to see what this solution actually was, we can go ahead and hit second and trace, and then we can go ahead and find our 0. Notice that is option 2. It says 0 because our zeros are solutions. Now to do this, you do want to go ahead and get your cursor to pop up on the screen. So notice I have this little cursor. I just kept clicking left until it popped up. Once I show it there, I'm going to hit enter, click to the right, until it passes the 0, and then hit enter, and enter again. And notice it says my 0 is -2. Once again, we could see that in the graph, but I just want you to see I got the same number that I have here. Now we're going to find this other 0. So I'm going to hit second, trace, go to 0, hit enter, and I'll click to the right until I see it pop up again. And there it is. It's below the 0. I'm going to hit enter. I'm going to click one more time, 2 more times until I see it go above the 0. I'm going to hit enter again and again. And it says it should be 2.4, positive 2.4. Now I know this is a fraction, 12/5, and we don't know if that's 2.4. But we can put it in the calculator to see does it give us 2.4. And if it does, then that is the correct answer. So I'm going to hit clear to get out of my graph. And I'm going to go ahead and type in 12 divided by 5. And notice it does give me 2.4, which is exactly what we found when we used the 0 feature in our graphing function of our calculator. So again, you can check all of these by setting them equal to 0 and graphing them if you want to. And you don't have to, right? But if you're doing a test and you have the calculator and you want to make sure you get 100, you might want to check all of them just to be sure you didn't make a small error while calculating things by hand using inverse operations. So hopefully this video was helpful to you and in solving these absolute value equations.